So today I would like to show you one solution for question concerning electrical analysis. Here we have a question for nodal analysis. Here we have a current source in this question with a value of 5 ampere, a current source of 3 ampere, and a voltage source of 12 volt. And as you can see, it's already labeled over here V1, V2, and V3, and this ground as a reference ground. There are 4 nodes, difference node here. So for those who are not clear how to define the nodes, you need to make sure it is non-identical nodes. As you can see here, this junction and these nodes and junction actually has an equal potential, and thus all these are equal to as a single node. Same goes to this point, and also this junction, this path. These 3 points actually has a same potential, and that's the reason why it equal to the value of V1. So by using nodal analysis, then we can find the value of V1, V2, and V3 with respect to the ground. So let's build up the first equation for the V1. For node V1, here we have a 5 volt. The nodal analysis is based on the current Kirchhoff law, where we can call summation of I in is equal to summation of I out. So here we can right now draw it as I1. You can call it this is I1 going into due to the fact that this is a current source in this direction. So in this path, the current should be go into the to this V1. So the 4 ohms, since this is the load or resistor, so we will call it as this is I2. So I2, and this will be the I3. This is also I4, and we have another one here as a I5. So we are certain that I5 will be in this direction, going out from this V1 to this direction. This is load. We are assuming this is I4 in this direction, I3 in this direction, and I2 in this direction. So next, what we need to build up is, now we can build up the equation, the summation of I in equal to I out. So we have I1 equal to I2 plus I3 plus I4 plus I5. From here, then we can rewrite this is straight as a 5 ampere in terms of value, and here you have what we have is V1 from this point to the ground. We have a resistance of 4 ohms. So for I2 we can rewrite as a V1 minus 0 as a ground divided by 4 ohms, plus for the I3 is in between V1 and V2 divided by 8 ohms. So we can rewrite as a V1 minus V2 divided by 8. Now we can rewrite as a plus, another plus I for this I4. So I4 here, the path of I4 is from V1 goes to the V3. So divided by 2. So this will be a V1 minus V3 divided by 2. And finally we have I5 with the equivalent of value of 3 ampere. So we have 5 ampere input, and all this V1 minus 0 divided by 4 V2, V1 minus V2 divided by 8, V1 minus V3 divided by 2. And finally, we have a V home done. So now we can divide it and simplify it. 2 ampere is equal V1 over 4 plus V1 minus V2 over 8 plus V1 minus V3 over 2. And this will give us, if we simply make it as 7V1 minus V2 minus 4V3 equal to 16. This will be our equation 1. So next, let's build up the second nodal for the node V2. Here, node V2, we have it shares between the one path with the node V1. So where you can see here, the I3 is same sharing between V1 and V2. So we use the assumption, maintain the assumption in this direction without changing the assumption to other directions. So here we have, now let's rename the rest of the path. So we have here as a I6, and we have this path here as a I7. So here you can see here for the node V2, there are 3 different paths: I3, I3, I6, and I7. So similarly, just like previous node, we write the equation for all these 3 paths. So for I3, now we have V1 minus V2 divided by 8 ohms. This is which goes into the path, and then here, and this will be equal to the one that goes out from the V2 node, which is the I6, which is V2 to the ground, which is 0, which is divided by 2 ohms, and then V2 and to V3, this is plus V2 minus V3 divided by 4 ohms. So by having this, we can simplify it right now, and finally we can rewrite it to become V1. There's a simple mathematics over here, 7V2 minus 2V3. So here we go, that we have a better second equation to be solved. And finally, now we go to solve the third nodes here, the V3. The V3 consists of I7, path of I4, path from I5, and a new path from V3 to the ground. So we rename it to become the path of I8 here. And for the node V3, for the node V3, then we can rewrite as usual, summation of I in equal to summation of I out. So let us determine which one are I in and which are I out. So we have here I in is the I4 plus I5 plus I7, which will equal to the I8. Right? So for the case of V2 just now, I forgot to mention the summation of I in equal to summation of I out, in which it is a I3 equal to I6 plus I7. Now we have a complete equation for all nodes. And now we revise this. I4 is actually V1 minus V3 divided by 2 ohms. We also have I5 is this, what we call as a 3 ampere, plus I7 is V2 minus V3 divided by 4, and finally we have this I8 is V3 minus 12 divided by 8. Completing this node V3 equation, then we can rewrite it as a 4V1 plus 2V2 minus 7V3 equal to negative 36 volt. When we write all these three equations back, now we can use simultaneous equation to solve the V1, V2 and V3 value. And here I don't want to dwell too much with the mathematics here, so I just share with you the results. So the V3 here, we can say that it is 184 divided by 15, which is equal to 12.267 volts, obviously. And we have V2 at 74 over 15, which is equal to 4.933 volt. And finally the V1 is equal to 10 volt. So here you are, the solution of this circuit analysis using nodal analysis, and I hope you enjoy this video.